my god. Nice.
Oh, okay then.
Okay, this one. Have a look at this. Yes, you may. That's fine.
I'll do this before.
Yes, Kylie Peck, you may go to the bathroom.
Don't say that.
Oops. Like this. Okay, so this is one where you've got to enter an answer. I want you to try this. You may, if you'd like, you may work with your neighbor on this a little bit, but I want to see if we can get an answer. All right, so here's the question. Take a second, and if you're okay, so I only want Chromebooks, or only people have Chromebooks that are in great shape, right? On the first one, is that right? Okay. Okay, so look at that, discuss it with somebody if you'd like to. Take a minute or two, and then we'll talk about it. I'll update grades soon. I'll update grades. What's this mean here? So what I would do, I think the reason people miss this, I'm convinced that if you miss this one, it's because you didn't know how to interpret that. In terms of f of x, what does g of x equal, right? So always start off, I think, with the template and just fill stuff in, right? So we know that if we ever want to transform f of x to a new function g of x, we're just plugging in values of a, h, and k, as long as we're not horizontally stretching or compressing, which we're not going to do, right? So we have to interpret, we have to find these values from the description up here, right? So what's it mean when we say that we're going to vertically stretch by a factor of 3? What's that mean? What value is that giving us? It's giving us a, isn't it? Yeah, it's telling us a equals what? 3. Okay, so then we can plug, one thing we can do is we can plug 3 in there, right? What's it mean if we say we're translating to the right by 3? That's h. So h is equal to what if we're going right? Positive, good, positive 3. So we can plug 3 in there. What's it mean if we're saying we're translating up by 10? That's k. K is equal to positive or negative? Positive, yeah. K equals positive 10. So we can plug 10 in there, and that's our answer. That's all we have to do. You can't do anything else because you don't know which function this actually is. We're just calling it f of x. We don't know if it's a square, if it's x squared, or if it's a square root, or if it's an exponential function. We don't know what it is, right? So our answer has to just be then 3 times f of x minus 3 plus 10. That's all we can do, right? If it were a square root function, then we could put this into a square root function. Or if it were a power function, squared, or then that's fine, but it's not. That's all we can do right there. Okay, that's written in terms of f of x. Questions? Does that make sense? Okay, that was the most commonly missed question.
That was the easiest question.
Well, it's really not hard, but I just think people maybe didn't understand how to write the answer. That's how you write the answer.
Oh.
Okay, next one. Let's see. That was the most. What's that?
Didn't you say we have a test tomorrow?
Yeah, you can do it today if you want to. When we're done here. Okay, the next most commonly missed one was this guy. So let's see. Oh, whoops. Okay, what about this? What about this? Just jot this down in your notebook. Write this answer down. We want the range of the function using interval notation. So first of all, what's interval notation? You got to know how to answer it. It's good parentheses and commas, right? Not using inequalities. So we want the range. Range is an important question or important element of this. Range means which variable are we looking at? Y's, Y values. Good. Okay. So think about how we're going to do that. The range of the function. Okay, so what do we think here? Riley, what's the bottom limit of the range, or is there one? Say it again. -4, good. So -4 is the bottom number. We're going to put a comma. What's the top limit, or is there one? Infinity, good. Okay, so those are my limits, or my endpoints, right? What kind of a symbol is going to go there? Okay, right now let's talk about this. It kind of looks like a bracket, because a bracket would mean it includes the value, right?
But it's not because it's an asymptote.
Okay, yeah, but the tricky part is it's an asymptote, the red line. What does that mean again?
That it never reaches.
Okay, it never reaches it. So as we go to the left along this function, the function keeps getting closer and closer and closer to a y value of -4, but never gets there. So now what should that symbol be on the left? Parentheses, only because it doesn't include it. Okay. And then on the right, what does it have to be? Has to be parentheses, because you can't include infinity, right? So that's the answer we'd want on that one. Okay. Let's try one more of those. How about? What number was that? This guy. Okay, how about, oops, end behavior, wrong one. Oh, what? Okay, how about this? Here's a range. Okay, write the range of that one, please. Okay, range of that one. So looking at y values.
Were there any new passwords?
I think is it rainy?
I could try.
Try it. I think it's rainy. It's either rain or rainy, I believe.
Spring. But then it became summer.
Okay, what do you think, Mallory? What kind of what's my lower limit of my y values, or is there one? So it'd be what then? Okay, what kind of infinity? Negative infinity. Okay, so negative. Okay, comma. And remember, I have to have that on the left, right? Everybody see that? Left correct, right? So we go from smaller to bigger. So the bottom is on the left, the top is always going to be on the right. What's my top limit for y?
5.
5, okay. Now, what kinds of enclosures do I need? What about on the bottom? It has to be round, right? It has to be parentheses, because we can't include that one. But the question then is, what about the top one? Is 5 included as a y value? It is. So Lacey, what kind of a enclosure do I need? Need a bracket. Good. So that's my answer. Okay? Everybody agree with that?
It
Okay.
said the password was incorrect.
Okay, so you guys need a password. All right, get your password. What if I were to like take a paper cutter, let's say this is an infinite sheet of paper, and I want to make a vertical cut on the paper to separate where it's decreasing and where it's increasing. Where is that line going to go? So here's my line. Where do I drag my line? Where do I drag the line if I want to cut the paper to separate where it's increasing and decreasing?
3.
3, okay, good. I want you to see something important here. Okay, so if that's the line, which side of that line is going to include, which piece of paper, the left or the right, is going to include the interval where it's decreasing? The right side is, isn't it, right? So then all we need to do is we just need to describe the x values included on the right piece of paper. That's saying that interval, right? Because we're always asking about x values. No, you're not testing, right? Raise your hand if you're testing real quick. Okay, good. All right, so how do I say that? How do I say that interval? X is what? I'm looking at this interval over here, right? The interval on the right. How am I going to say that? Bailey, how do I say that? How do I say that interval over here? This strip of paper includes what x values? Because that's where x is greater than. Well, what's the number going to be? Then we'll talk about the sign, the symbol. 3. Okay, so greater than 3. Is it greater than or equal to? This is another part you got to be careful with. No, it's not. Because at the top of the function right there, it's flat, right? If I were to balance a ball on the top of that, it wouldn't roll because it's not increasing or decreasing there. But if I nudge it to the right just a little bit, it's going to start rolling down the hill, right? So it's only greater than 3. Now, do I have to do anything else with this? The textbook always wanted to do something like we'd say, x is greater than 3 and less than infinity. No, don't do that. You don't need to, right? This implies all x values bigger than 3. There's another reason I think it's much better to write it this way. How many boundaries are there to this interval? How many? How many boundaries are there to the interval on the right piece of paper? I only made one cut, didn't I? Right? It goes forever to the right. There's only one boundary. At x equals 3. That's the boundary between increasing and decreasing, right? So then we only need one inequality because it's only bounded on one side. It's only got a lower limit, right? If I were to write this, in other words, using interval notation, it would have looked like that, right? Everybody agree? There's only one number. It's only one number. It's only bounded on the bottom, and so I only need that one inequality. I don't need to include the infinity and make it a double inequality, a compound inequality, right? Okay, so let's compare that to, so that's our answer, x is greater than 3. Let's compare that to, real quick, and then I think maybe you're ready to go on this.
I'm still not very good at end.
And okay, we'll do end behavior too, that's fine. Okay, how about this one? This is actually a really easy one. These look a little bit tricky, but you just got to be careful with this function, but these are probably the easiest ones. We want to know the intervals on which this function is increasing. Now keep in mind that this is one of those asymptote functions, right? So as the ant walks to the right, he's getting closer and closer and closer to y equals 0, but he never gets there. So he's actually always increasing, just very slowly after a while. So what's the answer to this? Where is this function increasing? On what interval is it increasing? What do you think? How would you describe the interval? Is there any place where he's not decreasing? So then he's increasing everywhere, isn't he? Right? How do we say everywhere as an inequality? Remember, that's the one where x is going to be greater than what? Negative infinity. And x is less than positive infinity. Oops. Right? Everybody agree? Now, what if the question instead asked where the function were decreasing? If this function said, if this word said decreasing instead, is it decreasing anywhere? If it's always increasing, it's nowhere decreasing, and so the answer just would have been NA. Okay? Last one I want to look at with these seem to be. Okay. If you want to go through, next one would be this guy. Okay, we already did that one. I think we're okay there. Really pretty good after that. Yeah, the only other one, the next one, and this is pretty easy. Would just be one like this, where we want to find out in which graph are the blue and red relations inverses. This is where they're inverses when they have symmetry about that diagonal line y equals x, so that's the correct answer. Right? These would all be wrong. Okay, you got it. That's it. Yes, sir. Anyone you want to. You have to. I'm going to put all three in the book, so you're going to need both the module 1s and the one module 2. Probably module 2, I guess, for most people. Yeah. Mm-hmm. Yeah.